Hello everyone, I'm back. I'm Frank. This is Frank Puzzles, and this is part 2 of Peaceful Destruction. Oh, I can't speak. I've gotten a decent amount of sleep now, and I'm ready to continue solving this puzzle. Let's go. Okay. So what we were doing was we were trying to figure out how these shapes work. Let's focus on one side. Let's focus on the green side. I don't know if that's the right side or the correct side or the wrong side to focus on. Or maybe let's focus on yellow. It's pretty symmetric except for the numbers here and then the circle here. Well, we'll probably have to look at both ways. So, let's focus on yellow first. This cell being yellow and the repercussions of that. So let's remove the red. Ew. Let's I guess no green here and no red here. So if this is yellow, this has to have 3 cells that are in the same region. So this is the third one. The red has to have 3 cells. And again, the reason why is because we tried to set it, we can't have it as medium, you can't have it as pink. We need ones to match pink or dark. And again, if we tried to have pink go down to the one here or dark go to the one here, then that's not enough space for the green region or the yellow region to open up to basically work. So this has to be a pink dark pair. So we have yellow here. That's 1, 2, 3, 4, 5, 6, 7, 8. Red has to go out, so it has to go out here. Red cannot block in green, so this is not pink. Pink has to go here. These can't be red, obviously. Yellow has to be one of these 3. Red has to go out. 1, 2, 3, 4, 5, 6, 7. It can go to here. It cannot block the green because this has to be green because green has to go out somewhere. But we still have 6 cells that we have to take care of for red. So green has to go here. This can't be yellow, because yellow cannot get to any of these spaces. So we need red in 6 spaces out of these 7. It can't block the green, so it can't go there. It cannot be part of this, because that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and only 2 spaces would be in the same region and the false region. So it's blocked by the 4, it's blocked by the 1, and it's blocked by this green. So the red has to go at most to here, or it has to be these. So either way, these are all red. So these are all red. And red is one of these and one of these. I guess this doesn't have to be red or pink. It could also be red or green. It could also be dark. So that's one thing. Dark has to be including those 2. Yellow cannot go here, because then it would block this cell from having a being in a region. So this has to be dark here. This has to be dark. This must be dark. So we have 1, 2, 3, 4, 5, 6, 7, 8. This must connect that way. We have 1, 2, 3, 4, 5, 6. I guess this could technically not be dark. 1, 2, 3, 4, 5, 6 guaranteed. So this is 1, 2, 3, 4, 5, 6, 7, 8, and one of these is 9. So then we have 1, 2 darks here, 3, 4. This has to be dark, 5, 6, 7, 8. We need to connect here, 9. So then this can never be dark. That's interesting. So it has to be dark connecting to here. We tried to have pink this way. Why doesn't that work? 1, 2, oh, 2, 3, 4, 5, 6, 8. Oh, because it blocks off the green. That's why. So the green can, yeah, the green goes 5 here. It's blocked by the pink here. It's blocked, it could be here, but then if it's not, this is not green, it's blocked by it, and it's blocked by the 1s. So we have 1, 2, 3, 4, 5 greens, maybe 6, maybe 7, but then it would be blocked by the 1s and blocked by the pinks here. So this would be pink, guaranteed. Oh, that's interesting. So then this would have to be pink this way, because the light has to go somewhere and it cannot go here. So then light would have to go this way. So then light would be done. Pink has to go this way. But then green, so then green has to go this way, if that's the case. So we have green, green, green. But then this can't go 5 this way, and this just doesn't work. Because there's too many digits here that don't have a color, right? Blue cannot go 2 that way, so that's stuck there. Light cannot continue on here, because if it did, and then therefore pink has to go down from that, which means green has to go down, but then that's already 4 greens. Green cannot go here, because again, to connect, you have to have 1, 2, 3, 4, 5, 6, 7 cells be dark. You have to connect with 2, and it has to be those 2. If it goes this way, it would block one of these cells from being in a region, because you can only have one of them be part of yellow. Interesting. So it cannot go that way. It cannot go to the yellow from the left, bottom left corner. It has to go green. Interesting. So then if this is not yellow, this is all green. This is 3 cells that are part of the region. Again, this is only 2, so it has to be either this way or this way. So this cannot be part of that region. That's the reason why. This is 3. These must continue on to connect. So none of these can be green, obviously. Red has to go this way, so this can't be yellow. Red has to go out here. So this is red, and again, this is blocked by the 4, because if you try to get to the 4, if you include the 4, then this is at most 2 cells in the same region, in the same false region and the real region, which is not allowed because it's supposed to be 4. So, and then the yellow region has to go out somewhere. So this has to be yellow. This can't be yellow anymore. We have 1, 2, 3, 4, 5, 6, 7, 8. These are guaranteed. And then because if you block off this, you don't have enough cells for the region. Same with this. Oh, maybe it could be that. Well, let's continue. Okay. Okay, let's go back. Let's try the green with that one, or the yellow that way. Maybe I messed up. So these are not red. This is not pink. This is all red here. This has to be red here. So could be avoiding that, and it could have all of these 6. It cannot, again, block off the green. This has to be green. This is pink. This is pink. Light has to go this way. So then this has to be light, light, because it cannot be part of this. This is obviously not light. It has to be pink to go out somewhere. So this, no, this still has to be green. Okay. Right, because this has to be green going this way. And then we still have the same problem, right? Then we have this problem here still. Okay, so that's, yeah, so it cannot go that way. It has to go the other way. So then this is green. And these can't be red. This can't be dark. And then this is red this way. So red has to go out here. None of this can be yellow, essentially. Yellow has to go out this way, so this cannot be dark. Yellow could go this way, though. So this is not green or could be yellow. Can't be green. None of these can be green. So then these are all red. Again, it cannot go back here because then that would close this cell from being in the red region. So one of these two is red. I guess this could be, sorry, this could be yellow also. Two out of these three are red. And then one is yellow. So this can't be dark either. So two out of these three regions are red. The dark has to go out here somewhere. So this is dark. And it cannot go here because it would block the yellow off. So then it has to go this way. So this is dark. So yellow has to be able to go here. So this is yellow. We have dark, dark. Blue has to go this way. And the problem earlier for here was that light could not go down. But blue can go up. So if blue goes this way, we have the same problem, right? Going the other way. Dark goes here. Yellow has to go here. Therefore, all of these are red. Yellow has to have only 4 cells here, so then it has to cut in here. And then pink can never get to here then, because it has to go through one of the greens here. So none of these are red. This can't be red. Oh, that has to be yellow? That's interesting. Maybe it doesn't. Maybe it could be pink. Yeah, it could be pink. Probably not, though. These could be technically yellow, I guess. So blue cannot go here. Blue cannot go here. Therefore, this is blue here. And that's the full blue region. So that's done. Orange has to go this way. So then this is orange. We have 6 oranges then. So we have 6, 7, 8, 9. It can't be 7, 8, 9 because then the orange would be in this cell and you'd only have 2 cells in the 3x3 box around it in the same region, in the false region. So this cannot be orange. We could go 7, 8, 9 there. That's possible. You cannot reach here, obviously. So orange cannot reach here. 7, 8, 9 is possible. 7, 8, 9 is possible. 7, 8, 9 is possible. So this is blue. Here, this must be pink because it cannot be green. Because again, if green goes back, well, there's only one more for green. If green goes here, this cell doesn't have a region because it's blocked by all reds. So it has to be pink, essentially, going out here. Yellow can't reach it. It's too far. So this kind of works. We know this is pink. This has to be pink here because it cannot reach dark. So these are region boundaries. We know these. These are region boundaries. One of these is green. How many cells are here? Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So only one of these can be pink. Wait, don't we have the same issue? No, it can connect this way. Right. So only one of these can be pink. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So then yellow has to go, but the problem, ooh. 2, 3. How does this work? I guess dark could go this way, maybe? How many cells do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It can't be 5 here, though. That's the problem. Okay, we're still kind of running into the same problem. It's not as bad, but... Hmm. 1, 2, 3, 4, 5, 6, 7, 8. The problem... Okay, so the problem is if it goes yellow, yellow, this doesn't form an orthogonally connected region. Uh... 1, 2, 3, 4. Oh, I see. Okay. So this allows... So, yeah, the reason why the other one didn't work was you couldn't have this be... Basically, it forced this to be red because the light had to go down, the pink had to go down, the green had to go down, so this was all red. This is open. So this can be... This can't be orange here, by the way. So if we have this be yellow, this could be red and red here. So it could be yellow, 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 that's 5. Ooh. No, that's no good. One, 2, 3, 4, 5, 6, 7, 8, 9. It can't do that. It has to go. Light, yeah, I can't connect there. Huh. We don't have enough spaces. Yeah. Because the yellow can't connect this way. You can only take one of these two. Oh, this is bad. Okay, so what? This has to have 3 in the 3x3 that are in the real and the fake region. So it's those 3. This has to be 2. It's those 2. This then has to be pink because red has to go around here. And it gets blocked by the 4 because it doesn't have enough cells to be part of the real and the fake region for 4 cells. Cannot go here because it's blocked by it could block the yellow from a region. So then it has these 6. It has 7, 8. Sorry, it has these 6. It's guaranteed. Yeah, light can't reach here. It's only 2 cells. Medium can't reach here. It's only 1, 2, 3, 4, 5 cells, and it can't even be that because then it would block off the light. It can't be yellow if it has, like, the problem is that this blocks yellow there, right? Hmm. Yeah, the problem is this is 4. One, two, three, four, five, six, 7. The problem 8. I mean, this could be medium still, actually. I guess technically this could be dark. 1, 2, 3, 4, 5, 6, 7, 8. Oh, that's how it works. But then there's too many yellows. That's the issue, right? There has to be only 4 yellows around here. So 4, 5, 6, 7, 8, 9. Oh, that works. Okay, so I guess that's the solution. Um, Dark has to get here, essentially, and the corresponding pink could not get to here because the problem is that would block the light off because light cannot go here, and then medium has to go this way. So, but blue can go here. Dark can be essentially all of these and still go there. And it has to then, because so green cannot be here. The pink has to connect. So the pink has, if green were here, it would block the pink because you only have one more pink, right? Dark cannot get to, it can get to 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's the most. Light can't get there, medium can't get there. So the only one that can get there is dark. So to connect, the pink has to go this way then, and this has to be green. So then we have 1, 2, 3, 4, 5, 6, 7, 8, 9 pinks. That eliminates pinks from the rest of the region. So no pinks. This has to be yellow. So this is done as a region here. This is done as a region here. The dark has to connect to here. So these are all dark. This has to be light then. This has to be light, because if it goes here, the problem is this is too many cells in that region. Yellow can not only be 4 of these, and it has to be 4, but if it goes this way, I guess that works. 1, 2, 3, 4, 5. No, it doesn't work. 1, 2, 3, 4, 5, 6, 7, 8, and these would have to be red. So then yellow wouldn't be able to go this way. So yellow has to go this way. So then this must be red. This must be yellow. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Yellow has to go this way. 1, 2, 3, 4, 5, 6, 7, 8. And then one of these is 9. We don't know which. And then we have 1, 2, 3, 4, 5, 6, 7, 8. And one of these is red. So that's fine. So then this is done as this is done as a border. The dark is done as a region. So we have dark finished. That means none of these can be dark. Okay. This obviously can't be yellow. If we tried to go, well, one of these has to be light here. Okay, so this can't be light. So this is medium to connect to here. 1, 2, 3, 4, 5, 6, 7, 8, 9. It could go that way. That is possible. This obviously can't be pink anymore. Okay, so then we know what these regions are, so that's interesting. Pink doesn't need a 2. Red needs a 2. So it has to be one of these 2 cells here. Because it can't be any of these. I guess it could be here. Okay. That doesn't help. So this could be 2, and we could have 2 here in the red region. Yellow. Okay, so this can't be 4 because it's part of the yellow. It's the 4 region here. We need a 2 for the yellow. So it's either here or it's one of these 3. Okay, we need a 2 for the blue region. So it's either here, here, or one of these 4. One of these 2, sorry. So the pink region cannot have 7 or 8. The remaining digits in the pink region are 3, 4, 5, 6, 9. 4 cannot be here because of 4 in the row. Green region, 4 through 9. This can't be 8 or 9. So this is 4, 5, 6, 7. So these 2 match these cells here. We're not sure which one is which, though. Okay. Obviously, this can't be light. Can this be orange? Yes. We have 6 here. Can this be... Yeah, I guess it could be 6, 7, 8, 9. So orange needs a 4. So one of these is guaranteed to be a 4 for orange. And this can't be 4. So this has to be 4 here. Right? 4 cannot be here in the blue region. 4 can't be here because of 4 in the row. So 4 has to be here. Which eliminates 4 here. Orange needs a 4. And it can't get a 4 anywhere else here. And it can't get a 4 here. So then it has to go this way. So this is orange guaranteed. We have 1, 2, 3, 4, 5, 6, 7. We need access to an 8 for orange. And none of these can be 8. So therefore, this must be orange also. So I have 1, 2, 3, 4, 5, 6, 7, 8. You cannot have 1 digit here because then that would mean only 2 cells are in the same region and the fake region here for orange. So this cannot be orange. This must be medium. So then where can orange go? We have 1, 2, 3, 4, 5, 6, 7, 8. And it has to go here as 9. So this is 9. This cannot be orange here. This cannot be orange here. So this is 3 cells in the real and the fake region. So orange is done as a region. And this is a 3 as part of the medium region. So this cannot be 3 here. Okay, the remaining digit here is 2, 3, 5, 6, or 7. And it's the same as this digit. Okay, let's just remove all the 2s at the corners. Remaining gray region cells. We have no 1, no 3, no 6. So we have what? We need access to a 4. 4 could be any of these. Okay. No, 4 cannot be any of these because of 4 in the row. And 4 can't be here, and 4 can't be here. So where's 4 in the gray region? It has to be here. So this is 4. We have what? 2, 5, 7, 8. So 8 cannot be any of these. This has to be a 2, 5, 7, 9 quadruplet for the gray region, which eliminates 2, 5, 7, 9 in the rest of the row. So this is 3 or 6. That matches this cell. So this is 3 or 6. And this must be 3 or 6 here. This 3 eliminates 3 here. Okay. Okay, so then the last digit here has to be an 8 for the medium gray region. Let's start marking some letters, I guess. This matches one of these 4. That's not helpful. Let's do this one. This matches here. This matches this, so that's going to be B and B. A's here, A's here, A's one of those two. That's fine. 3 cannot be any of these cells, so 3 has to be one of these 2 here, which eliminates 3 in the rest of the row, so this can't be 3, this can't be 3. Where is 2 in row 4? These can't be 2 because of 2 in the regions or 2 in the column. This can't be 2 because of the 2 in the region. This can't be... Oh, it's one of these 2. Never mind. Thought I had something there. Never. Well, it's one of those 2. Okay. This 2 eliminates 2 here. Remaining digits in column 7 are 4, 5, 7, 8, 9. We know the dark needs a 6 also. So the 6 has to be one of these 3 cells also, which eliminates 6 in the rest of the row. But it could be with 5, 7, 9. So 4 can never be here. 4 is guaranteed in one of these cells here for the dark region. So this cannot be 4. This is 3, 5, 6, 7, 9 as possibilities. Okay. That means this digit cannot be 3 or 6, no 1 or 4. This is 2, 5, 7, or 9 here. Four could be here, or 4 could be here. That's fine. We need a 4 in the green region. So the 4 has to be one of these 2, which eliminates 4 in the rest of the column. We have a 3, 5, 6, 9 quadruplet in column 2, which eliminates 3, 5, 6, 9 in the rest of the column. So this is 7, 8, no 5, 6, 9, no 5, 6. We have a 4, 7, 8 triplet in column 2, which eliminates 4, 7, 8 in the rest of the column. So this has to be a 2 here. So this is 2. 4's guaranteed to be there, but we already knew that. Where is 4 in row 4 then? Can't be here because of 4 in the regions. Can't be here because 4 has to be one of these cells, and can't be 4 because 4 in one of the columns. Can't be 4 here because one of these 4 has to be 4. So this must be a 4 then. That's the only place for 4 in row 4. So no 4 here, no 4 here. Where is 8 in row 4? Cannot be here because of 8 in the region. It could be here. Dang it. Okay, never mind. This can't be 9, though. So yeah, this could be 8. I messed that up. Okay, well, that didn't affect anything else, so it's fine. Let's see. 2 is here, so this cannot be 2 here. This can't be 3 because of 3 in the row. Remaining digits in row 2. We have 5 through 9. Okay. Where is 3 in column 6? It has to be in the yellow region. So therefore this can't be 3. No 1 or 4. 2, 5, 6, 7, 8, 9. I guess let's finish the rest of... that's a lot. Remaining digits in row 6. We have 2, 3, 4, 5, 6, 7. Okay. So no 4 here, no 4 here, no 4 here because of 4 in the column here, 4 in the column here, 4 in the column here, and then 4 in the column here. So where's 4 in row 6? It has to be here. So this is 4, which makes this 8. Oh, wait, this B is not the same as this B. There's 4 and 8 here, which makes this 7. We're guaranteed a 9 here, so 9 cannot be in the rest of the pink region. You're also guaranteed a 5 here, so 5 cannot be in the rest of the pink region. Therefore, this is 6. This can't be 5 or 6, it's 4. This 8 has to be somewhere here in column 1, so it must be there. So that means this cannot be 8 here. So the gray region needs access to an 8, and it has to be here then. So this can't be light, this is gray, this can't be medium gray, this is light. So we're done with that region. Okay, that means 8 cannot be any of these cells. Can't be here. This is 4. We have a 6 here, so that eliminates 6 in the rest of the pink region. That leaves this as a 6. So this is 6, which forces A to both be 3s. So those are 3s then. That eliminates 3 in the rest of the orange region. We have 8 here. This is 3, 5, 9. One of these digits is 5, 7. We have a 3, 5, 6, 7, 9 quintuplet in row 4, which eliminates 3, 5, 6, 7, 9 in the rest of the row. So this can't be 5 or 7. This can't be 5 or 7, so that makes this 2. This makes this 8. 2 cannot be here. This can't be 6 because of 6 in the row. This can't be 6 because of 6 in the row. Same with this. We have a 5, 7, 5, 7 pair in column 9, which eliminates 5 and 7 in the rest of the column. So this can't be 5 or 7. This is 6. No 6 or 6 or 8 here. We have a 5, 7, 9 triplet in the light region. So therefore that eliminates 5, 7, 9 in the rest of that region. We need a 3 to access for the light region. So this is 3. That eliminates 3 here. So this is 5, which eliminates 5 here. So it's 7, which eliminates 7 here. So this is 5. 5 eliminates 5 here. So it's 9, which eliminates 5 and 9 here. So it's 3. So this cannot be 9 here. That means none of these can be 9. Whereas 9 in the dark region, it must be one of these 2 cells. So this cannot be 9 here. This 6 eliminates 6 here, so this must be 5. 5 eliminates 5 here, so it's 7. This can't be 7. No 7 here, no 7 here. There's no 5 or 7 here. This is a 3, 6 pair. 5 eliminates 5 in the rest of the dark region, so this can't be 5. This is 7. This can't be 5 or 7. It's an 8, 9 pair. This 7 eliminates 7 here, so this is 5. Which eliminates 5 in these cells here. This 5 eliminates 5 here, and this 5 also eliminates 5 here, so this can't be 5, that's 9, which means this can't be 9 here. There's no 9 here, there's no 9 here, so this is 8, which makes this 9. That means this has to be a 2, 7 pair here in rest of row 5. That eliminates 2 and 7 in the rest of the yellow region. So no 2 or 7. Eight eliminates 8 in the rest of the column. No 7 in the rest of the red region. Okay, this can't be 7. No 3 here. No 8 here, no 8 here. This is 2, 5, 6, 7 as possibilities in column 8. 3 eliminates 3 here, so this is 6, which makes this 3. That eliminates 3 here, and it couldn't have been anyways because it's red. No more 6 in column 4. Remaining digits in row 8. We have 2, 5, 6, 7, 8. And again, this can't be 6, no 8 because of the cells in the column. This can't be 2 or 7 because of the 2, 7 pair in the yellow region. Well, we are missing a 3 in column 6 and in row 6, so therefore this must be 3 here. I mean, sorry, we're not missing a 3. There's only one place for 3 in both of those areas. Okay, so we have 1s. 2s are not quite done. Hmm. 2, 7. 7 cannot be in the red region. This can't be 7 anymore. This can't be 7 anymore. We have a 5, 6 pair in the blue in column 8, which eliminates 5, 6 in the rest of the column. This can't be 5, 6. This is 2. This can't be 2, 5, or 6. It's 7. So that means this cannot be 7 here. 2 eliminates 2 here, so that's 5 and 6. We need access to a 4 for red, and the only 4 can access is here. So this is 4 here. This cannot be 8 because of 8 in the row. We're guaranteed an 8 here in the red. Does that help? Not really. Oh, this 5 eliminates 5 here, so this is 9, which eliminates 9 in the rest of the row. Hmm. Yellow needs access to an 8. Well, we already know that, one of those two. Same with the red. Okay. We have a 2, 5, 6, 9 quadruplet in column 5, which eliminates 2, 5, 6, 9 in the rest of the column, so this must be 7, which eliminates 7 here, and this eliminates 7 here. We are guaranteed a 6 and an 8 for the yellow region, but that's not helpful. 5, 6, 5, 6. Okay, let's mark these. We have A and B. So this must be B. Is that helpful? Not particularly. Hmm. Either of these could be yellow, either of these could be red. Oh, we need a 2 in column 5 now. We have a 5, 6, 9 triplet, which eliminates 5, 6, 9 in the rest of the column, so this is 2. 2 cannot be part of yellow because we have a 2, 7 pair as yellow here. So this cannot be yellow. This is red, which means this can't be red. That's yellow. So now we're done with the regions. 2 cannot be here. 8 has to be one of these. 5, 6, and 9 is fine. So 6 has to be one of these 3. So this cannot be 6 here. Because, yeah, so this is 5 or 9 here. We have a guaranteed 6 here. That's not helpful. Okay, B cannot be any of these cells here. That's not helpful. Where is A? A has to be one of these 3 cells. Ugh. This 5 or 6 must be one of these two. We're gonna make it Z, I guess. Z and Y. So Z has to be one of those two. Y's here, so Y can't be either of those. So Y has to be one of these three. Uh, um, hmm. I don't see any other destruction because these all cannot be Sudoku boxes, right? We have 2 1s here, we have 2 7s here, 2 3s here, 2 9s here, 2 1s here, 2 8s and 2s here, 2 3s here. This doesn't have a 1. We have 2 1s here. So none of the destruction rule is helpful here. I think we just have to maybe try these digits. Ooh. Hmm. This digit here has to be one of these two. That's not too helpful. um, yeah. Digits in a circle. Yeah. We're all done with that. So I think the only thing we can do is just like do normal Sudoku or try things out. Um, I think we just have to try things out. That's the easiest way of clearing. Okay, what happens if this is 8? If this is 8, this becomes 8. This becomes 5 or 6 and is A. So both A and B would see this cell, so then this would be 9. This would have to be A here. So that would force... So this would be A. This would be A. This would be B. I guess that would be... Oh, and we have a contradiction. Right, so this would be A, that would be B. Since this is B, this can't be... This would have to be the A here. Where is B in this region? It has to be here. But then we have a 5, 6, 5, 6 pair, and then a 9 here, and that would be 5 and 6, and that's not possible. Oh, I guess that was the way. Is what happens if this is 9? That eliminates 9 from both of these cells. That's where we go for the irregular Sudoku. So if this was 9, that would force both of these not to be 9, and we wouldn't have a 9 in row 7. So this cannot be 9, this must be 5. Okay, that's a solve. Which makes the B's 6. So B's are 6 then. A has to be 5. Z must be 6, and then Y must be 5. So that eliminates 5 from the rest of the yellow region, which eliminates, which means that we have a 6, 8, 9 quadruple or triplet in column 6. This can't be 9. This is 2, which makes this not 2. That's 9. This 2 eliminates 2 here, so it's 7 and 2. 7 eliminates 7 here, so it's 5 and 7. This 5 eliminates 5 here. And this 6 eliminates 6 here, so this is 9. Which makes this 6, which makes this 8, which makes that 9. This 8 eliminates 8 here, so it's 5. It can't be 5 or 9. Therefore, it's 8. And that's a solution. Yeah, I guess it wasn't too bad. I don't think I would have been able to do this yesterday though. My mind was just I was very tired. And couldn't really concentrate on anything. So yeah, pretty cool actually. Yeah, the geometry behind this was very fascinating actually. Is how could you get these in the certain areas? And there was only really one way to do it, so you're sort of forced down that path. I was just like, I don't know where this can go. It's like, oh, it has to be dark because we don't have enough cells here for other regions to make it. But pretty cool, pretty cool. I overall enjoyed all of the destruction puzzles, so that was a lot of fun. Mainly because I love chaos construction, so the chaos construction rule set was pretty cool. But also the cells that match the circles that force the cells to be fake and real was kind of interesting, actually. That was an interesting. I guess that's the. There's really two rule sets here. There's kind of the destruction, which is a sort of variant on chaos construction, where basically you also have that the regions cannot be the digits 1 through 9. But that's not very restrictive. The restrictive part is really the circles, where basically you have circles which tell you how many cells in the 3x3 region are both in the real region and the fake region. And that can lead to a decent amount of restrictions. And it did in this case, I guess. Well, that and the digits, actually. Forcing certain specific ways that this could work, right? Overall, very cool. I love the whole destruction set. Again, probably because I like Chaos Construction rule set. And this is basically a variant of the Chaos Construction rule set. But an interesting one, nonetheless, right? So I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.